I was going pretty strong with my no-vid November, but here we are. Today I've got a couple of small, quick projects I'm rolling into one. You're getting a twofer. We'll be making this simple yet extremely critical part for John over at NYC CNC out of this stuff. And fixing these simple yet extremely critical parts for Quinn of Blondie Hacks. As we like to say here at This Old Tony Studios, no job's too small not to milk for a vid. Quinn's home shop is pre-Type 1, and she, understandably, is having trouble getting into space. By the looks of it, we've got some out-of-spec parts that need fixing. Granted, my pre-25th century history's always been a little rough, but I think this is a magnetic flux pump valve stem and a hydraulic crankcase pneumatic slide plate. To be fair, these Gen 1 parts have always been tricky. But we'll start with this one. This, I'm told, is an antenna, or it will be, and it's for John. I mean, not for John, not quite yet. It's a project he's working on, but we'll get to that in a minute. This isn't the first time his name's come up here. If you're watching me, you'll likely know who John Saunders is, and Quinn for that matter. If you don't, links for both down in the description. John and the gang have taken on an impressively daunting project. He's building, from what I understand, a life-size replica of the Johnny 5 robot from Short Circuit. That's the antenna right there. I'm willing to bet that reference means nothing to more than half of you, but suffice it to say, it's quite the project. I do envy their enthusiasm, in a sort of Evel Knievel jumping the Grand Canyon kind of way. Insanely cool, but better him than me. Here, let's go back in time, and I'll show you how this all started. Maho man, I've got to be a Maho man. Maho man, I've got to be Maho man. I've got to be. Hello.
I need a hero.
Hey, good to hear from you, John. A hero, you say, huh? Well, you've called the right place. When do you need him by?
I'm holding out for a hero till the end of the night.
Okay, that's a little tight, but tell me, does he gotta be strong?
He's got to be strong.
How about fast?
And he's got to be fast.
Does he need to be fresh from the fight?
Got to be fresh from the fight.
Yeah, don't they always? I'm on it, buddy. Fortunately for me, John's hero turns out to be a class project, and I'm only making one part, an easy part at that. And this is why I always recommend putting your money into a nice sturdy vise. That, and never buy material with a Poisson's ratio greater than 0. None of that 0.3, 0.4 stuff. That's how they get you. Now I know what you're thinking, a Johnny 5 replica. You talk about biting off more than you can chew, right? I thought the same exact thing. So I fired up the lathe, traveled to the future to see if he actually pulls it off. And he does. Though, just between me and you, the whole Johnny 5 thing turns out to be a cover story to get everyone to build him a robot he needs to transfer his consciousness into. This antenna is his only way in, but he pulls it off. Saunders is now wheeling around in the 28th century calling people bozos and flipping them the bird. I think that's what happened in Short Circuit anyway. It's been decades since I've seen it. Order of operations on this part might be a little tricky, but the first step is to rough it down to its major diameters. Grossly get it to shape, both the diameters and the length of each step. Here the most material is coming off, I guess, the stem of this antenna. It's going from 7/10 of an inch down to 1/4 of an inch right on the nose. And you may notice the smaller the diameter gets, the less my depth of cut is. I don't want to risk breaking it or bending it or who knows what. And the thinner this gets, the more important my spring pass will be. Here you can see how much that last cut deflected the now thin part. I haven't added any more depth of cut, I'm just taking another sort of ghost pass, but you can see it's still taking off material. This stock was springing away and this is just a cleanup. Let me give you the what's what. I sort of messed up this part. Well, I mean, I didn't mess it up. The diameter is 0.25 exactly, but But I could have been smarter about this. This part gets a ball end turned onto it. Full round on a 1/4 inch diameter, so if I did my math right, that should be an 1/8 inch radius. I don't have an 1/8 inch radiusing tool for my lathe. I suppose I could grind one, but my margin on this job is pretty thin already. What I do have is an 1/8 inch rounding bit for the mill. I just clamped that into a tool holder, tried to orient it as sort of flat as possible. One of the 4 cutting edges as horizontal as I could get it. Since this is bronze, you could probably even use an 1/8 inch round over bit for a router. Clamp that into your tool post or braze it to the end of something convenient. But this is sharp and I'm hoping it does the trick for me here. The potential problem I'm up against now, again, this part is really spindly. And a form cutter like this one's going to put a lot of force on the end of that part. Had I not been daydreaming while I was turning this diameter down, I may have turned it short, like not cut the full shoulder, only cut enough of it to give me clearance from my form tool. That would have left me with a much stouter part. Cut the ball in, or at least rough it in, and then finish the entire length of the diameter. I hope that makes sense. Keep the part as rigid as possible for as long as possible, just to make life easier on ourselves. Sorry I had to move the camera. Apart from bumping into it a few times, I've had to break out my Optivisors. I'll take it. So that's the top end roughed in. Like I said, I'm trying to do this all from one side, meaning I haven't flipped the part. Anyway, almost through with the lathe work. I've now got a large partial radius to cut into the top. You see that big dome head on the part? Well, I've got to cut that in next. The easy way out of this, again, is to make a form tool. But because it's not a full radius, it's not a full 90 degrees like it was on the tip, that form tool would be custom to this job, and I'd never use it again in my life. Truth be told, according to John, the features above this flat are non-critical. So I could just file a radius in. Any radius that looks good enough, I suppose. But what's the fun in that? Instead, let's take a chance, live a little, and do something I've never done before. Let's use the radius function on my DRO. Pushing this button is simple. And it does 2 things. First, it increases the chance of completely scrapping your work to like 87% at least. And second, it should walk us through cutting the radius we need step by step. I mean that literally, it'll turn the radius feature into a bunch of steps. Based on our input, it'll calculate a series of XY moves, or XZ moves on the lathe, to get you a very close approximation of the curve that you want. It'll look like a bad resolution image of the feature we need. Now sure, you can pick what resolution you want, but too many and we risk losing our minds. And there's my first step. It's telling me to go to 0, 0. I'm already there. I'm gonna push down. Step number 2, it wants me to take Z to 22 thou and some change, and X to 5/10. And then as I scroll through that, it's gonna tell me all of the steps I need to take to cut that radius. Just to drive this home, I'm using the radius function of the DRO to cut this feature. Once set up, I just move the tool until both X and Z display read 0. It's doing the math, I'm just turning the handles until the number reads 0. Then I go to the next step, move to 0 again, go to the next step, move to 0, and so on. It is a little weird as I'm not even looking at the part. I've got both hands on the wheels and I'm watching the DRO. I don't want to follow all of the DRO steps all the way to the end, since that would cut a 180-degree ball end, which would cut my part in 2 pieces, and I don't want that. My apologies, had to move the camera. This town's just not big enough for the both of us. I had to get in there close. I'm wearing all 4 pairs of my Optivisors, and I'm being very careful to file off just the high spots. The radius I'm looking for, the surface that I want, is at the bottom of all those little stair steps. I just want to knock the tops off without eating into the surface that I need. The radius on the print is 353, which is pretty darn close to a 9mm radius gauge, which is 354. Yeah, it looks pretty darn good. Again, I think it's purely cosmetic, but I'd like to stick as close to the print as I can. The major diameter, the minor diameter, and sort of the thickness or the width of this rounded section are to spec. So I think that radius is sort of in the right place in space relative to the part. Here's a quick tip for you, a little productivity boost. In order to switch from your vise to your dividing head, just hit Control-D on your keyboard. Sure, it might only save a minute or two compared to getting all the bolts out and tramming everything in, but at the end of the day, it can really... This antenna has a castellated end. It's gonna look like the top of a castle, I guess. To do those divisions, I'm using my dividing head and a 40 thou, 2 flute, ball nose end mill. I don't think on video you can really appreciate just how small these things are. I broke 3 of them just trying to get them out of the packaging. But for reference, here's 1 human hair. Something we should talk about. I think it's worth bringing up as I see this sort of thing a lot. This is what I'll be machining. That's what the features look like at the top of the antenna. This is what the original CAD looked like. The CAD that I received. The differences perhaps are subtle, depends who you ask, depends what this part's job is, but the original CAD is not manufacturable, or not easily manufacturable, let's put it that way. The cut is tapered, has like 5 thou radii, which means it's essentially square, and the bottom, the base of all those castellations are round, like they're cylindrical, concentric with the antenna. Now, sure, if it was important, there are ways to do this. You could, I don't know, EDM those features in, or 3D metal print this part. Maybe you could cast it or forge it to shape. Moral of the story, all of those are more expensive options compared to your vanilla machining. No offense to John and the gang, 9 times out of 10 when you see features like this, it's usually because someone was having fun in CAD and the particular details in those areas aren't very critical. They're just perhaps trying to make it look good. That, or it's being designed for 3D printing. 3D printing, all bets are off. With those things, you can make parts inside of parts inside of parts. That's tougher to do on a milling machine. Again, I'm sure the NYC CNC gang know what they're doing. They probably just figured they'd put something in and then deal with it when they were making it in-house. Fast forward a couple of years later, everybody's forgotten about it. They've now sent it outside to someone who's busting their chops. But again, this happens a lot. It may have even happened to you or someone you love. One of 2 things usually happens at this point. First, you may have a sensible, compassionate vendor who has the time to call you and talk to you about it. Come on, times are tough. They can tell you're an idiot in the CAD, but they're nice on the phone because they could use the work. Or second, you've got a real card on your hands that runs an EDM that's been sitting idle doing nothing other than burning out broken taps in-house. They see your drawings, that's what you asked for, that's what they're quoting. Cut to the water cooler where you're now complaining to your manager about the $2,000 part. I mean, can you believe some people? $2,000. Last time we saw this dividing head, we were using the plates because we had weird numbers of divisions to cut. 17, 23, that sort of oddball stuff. Since on this part I need 12 divisions, I could use the indexing plate, but it's got a rapid divider built into it too. This has got an additional plate installed between the body of the dividing head and the chuck with 36 whole divisions. There's also a pin I can drop in and lock it into integral number of divisions. So any whole numbers that go into 36, 2, 3, 4, blah, 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 12, I can do faster with this plate than I could with the little dividing plates that you install into the spinny handle. Some of you may have noticed what, at first blush, appears to be a surface blemish on this part. Something perhaps a less vigilant hobby machinist might do. Maybe accidentally bumped a finished surface with a lathe tool, when in fact, it's a very cleverly disguised nano GPS. So Mahoney and Captain Harris can find Saunders 5, of course. So that's it, I think. Surface finish could have been better. Buffing your tool marks is always a sign of professionalism. But for now, I'm just going to ship this off to John and dig into Quinn's parts. Oh, one last quick tip before we go. Instead of going to all the trouble of boxing your parts up, you can ship them by pressing Ctrl S on your keyboard. Huh, that usually works. I gotta push harder. Ah, Well, thanks for watching.